So next up, we have two colleagues from Google who would be sharing with us their thoughts on what are the basic steps for SRE, the basic understanding for SRE. And we have Gaurav and Rahul who would be helping us out. Gaurav is a highly motivated and self-driven cloud engineer with solid background in distributed system design, deployment, building scalable and highly available systems. Prior to Google, he has worked with LinkedIn as a senior SRE, and in his leisure time, he loves traveling. And this year's achievement has been that he's traveled almost 13 countries only in this year. Wow. Then we have Rahul. He's an experienced networking engineer and SRE at Google with demonstrated history of working on global scale services and systems. In his leisure activity, Rahul is an avid enthusiast of anime and is involved in organizing events within this community. So, ladies and gentlemen, please give them a big round of applause.
I think the clicker should be there. No, this one? Technical difficulties. One sec. There we go. Is the clicker working? Yeah. Okay. Morning, guys. I hope you guys can hear me loud and clear. So, I'm Gaurav. I'm part of the cloud customer engineering team based in Singapore. And today we are going to kind of talk about basics of SRE, at least how we do it at Google.
My name's Rahul. I am a site reliability engineer at Google. I'm currently working on Google Maps, and prior to Maps, I used to be an SRE on Google Software Defined Network. I've been in the company for about 7 years, so yeah.
Okay, so we're going to kick off this session by talking about the most important thing, what worries us about reliability. Is it power outages? Is it like a bad code which gets pushed to production, or is it something else? At Google, with our established SRE principles and practices, we actually handle this problem, and that is what you're going to see, today throughout this session. So, what we're going to cover today is like broadly around these 5 areas. We'll start talking about what SRE is. Then we'll kind of shift and understand what are the key principles, practices, and expertise which fall under SRE. Then we'll kind of summarize everything for you guys to kind of what are the ways in which you guys can start with all these principles and practices and build practice within your organizations. And lastly, how can Google help you in your journey in building that particular practice? Okay, so let's start talking about what SRE is and what problems the SREs solve. Now, if you talk about the TCO of a software, traditionally the way it works is you have the development teams, and their focus is just to get the features and functionalities out. And then you have the operations team, whose primary task is to make sure that the software runs well, it's scalable, it's reliable, and the overall system is working correctly. Now, if there's 1 month of development effort in producing a software, and that equates to 10 months of operational effort, then that's something which is not a really scalable thing. So that's something which needs to be fixed. So if you see this slide, you can see there are 2 aspects. So you have the development teams, and then you have the operations team. So the development teams, they just focus on kind of building the new functionalities and features, and as soon as it's done, they just shift it over through this proverbial wall, and then you have the operations team whose task is to kind of make sure that whatever the new features are coming in, they are in line with what's already running in. So this particular model is not really scalable because it creates a lot of friction. The operations team primary task is to make sure that the overall system is healthy. Plus, they also need to make sure that the new features, new functionalities which are coming to the system are well aligned as well. So, as I said, there is a lot of friction which kind of comes in. So how do we solve that friction? So if you see this slide, you can see there are, right from the moment you think of developing a product till the time it goes to the market, there are 3 basic teams involved in that overall cycle. You have the business, you have the development, and then you have the operations. Now, between the business and the development, the silos and the friction gets solved by using the agile methodology, but that's not the only wall you want to break. You want your development and the operations team to be part of the same, you want them to probably be on the same page. So how do we break the wall between development and operations team? And we can do that by DevOps. So we'll see how we can kind of have a better collaboration between the development and operations team and make sure that the overall cycle of kind of releasing a product or a service is smooth. So there are many definitions of DevOps. And what we at Google think DevOps means, it's basically a set of practices and guidelines which help reducing the silos across different teams. Primarily the development, the operations, the systems, and all those teams. And if you talk about the key specific areas which DevOps focus, so the first being to reduce the organizational silos, we accept failure as normal, we plan for it, and we fix it. We don't repeat it. Smaller changes are easier to implement and roll back rather than going for like a big bang approach. We make sure we use enough tooling and automation. We just make sure to avoid as much of manual intervention as possible, and measurement is critical to success. So we just make sure that we measure everything. So how different is then SRE from DevOps? So SRE kind of follows the similar guidelines as DevOps, but they focus a bit more on using data for decision making. So SREs treat operations like a software engineering problem. And the key part is we hire people who can basically write software. So it's not that SREs do the traditional classic operations. So we always make sure that we have a good mix of people who can actually write software. And the software is nothing but to kind of make sure that the overall operations part is automated. Their focus is also to kind of make sure that the overall system architecture is reliable. They're part of the design and the build processes as well. So if I have to summarize what do basically the SRE teams do at Google, so they, as I said, they treat like any problem as a classic software engineering problem. So basically we write software, we build solutions, and make sure that the overall systems run scalably, reliably, and efficiently. And of course, data being one of the primary guiding factors in doing all of these things. So if DevOps is basically a set of practices and guidelines, SRE is an implementation of those principles and guidelines in a particular job role. And again, the key areas of focus for SRE remains the same. So during this talk, you will see that how these 5 key areas are being implemented from an SRE perspective. Over to you, Rahul.
Thanks, Gaurav. Error budgets, the key principle of SRE. So much of the feedback loop that drives the SRE paradigm actually revolves around error budgets. And you might be asking, what do I mean by that? Well, what we hope to do today is explain and emphasize the importance of error budgets, as well as how we came about this conclusion. So our goal is reliability. We need to measure the reliability of the service with the understanding that the users are the most important feature we're developing towards. So let's look at what we have here. We've got good time over total time. And what's that giving us? It's giving us, the fraction of service availability. That's pretty good, right? It's nice. It's intuitive for us to understand. But how effective is this when measuring reliability of a service? Are users happy with the fact that, the servers are actually just up, the availability of the servers? What happens if your servers or service, to better say, is in a partial state? What if it's up but serving errors? What happens if one of the 3 servers are down, but the users are okay? They're not seeing any errors. Does that affect the reliability of your service? Well, the thing is, it's not that easy. The reliability of the service changes. It changes depending on the service, the customer requirements, how distributed the service is, how complex the service is. What we need for this is a more fancier approach. So what we need to do is step back, and we need to think about how users interact with the service, and thereby measuring the reliability based on those interactions. That approach actually answers some of those earlier questions. Users don't care about whether 3 of 3 servers are up for your service. What they care about is whether their interactions with the service is what they expected it to be. So what does that make it happen? What happens to that approach now? So before it was good time over total time, like uptime of your server. What it is now is good interactions over total interactions. This is much more effective when it comes to representing the reliability of the service. Okay, I think most of you have seen this. Reliability is measured as a goal of 9s. And it's pretty scary as you go towards 5 9s of availability, of reliability. What's that, like 5 minutes of downtime per year? But not all services have aggressive reliability goals such as that. But what's important to note out of this is that what we're trying to do is aim for the reliability of the service, trying to define that. But the other way that you can think about it is how much downtime am I willing to tolerate? And that leads very nicely into error budgets, which we'll get to very soon. But before that, something to not make you freak out about these numbers is that the downtime that we're willing to tolerate is considered as hard time, hard down. So that is 100% errors or 100% unavailability of the service. The reality is that there's a lot more nuance and room to maneuver if you're looking at measuring the brownouts, not considering things such as 100% or 0%. As an example, if you have 1% error rate for a 3.5 9s availability, that gives you 36 hours before you have any violations, compared to 21 minutes for a 100% error rate. You can see that 100% reliability isn't listed on this slide. Ben Traynor, the founder of SRE at Google, says 100% is the wrong reliability target for basically everything. Why? The costs to maintain reliability grows exponentially as you tend towards 100%. These costs and investments into reliability slow down your operations, as well as monopolizing your resources. And what do you get for it, for 100% reliability? You don't get anything apart from diminishing returns from your users. This is where error budgets come in. So before we get into the benefits of error budgets and how you can optimize it, the product teams and SRE come together and define your availability target. The downtime that we're willing to expect for that availability target, as per the previous slide that we saw, becomes your budget of unreliability, or better known as your error budget. With the appropriate monitoring, measuring the availability of your service in whatever definition you have for availability. Just to step back, that's based on the good interactions that we spoke about earlier. What you can do is use the difference between the actual performance to the target performance, and that difference becomes how much time remains for your error budget. We've been talking a lot about error budgets, but how is it effective? What's useful about it? Well, now you have data to drive your investments and reliability control loop. You're able to manage your change velocity with your investments into reliability of the service. This is powerful. The business now clearly knows what they need to put their money into. There are obviously a couple of other things that we've listed here. I'll get to a couple of them throughout the presentation. But some of the things to note for is your development team can actually manage the risks of releasing changes by themselves if they have an error budget to work with. And we'll go through a bit of that a bit later. To put this into some industry terms, I've just been using the word availability target, but what really is that? SLOs. So if I run the availability target through a thesaurus, what you get is your service level objective, your target for fraction of successful interactions. We said that we needed to measure our reliability of the service, your availability. So what that is your service level indicator, some sort of metric that contributes towards your measurement of reliability. We also have service level agreements, and this is a nice business extension. It provides a predictable reliability of your service, communicates that to your customers with the consequences of with consequences if you tend to exceed those agreements. Usually these consequences are in the form of monetary compensation. So we know SLOs are important. We need to have good definitions of what our user interactions are. Uptime of a server isn't really that useful. We can use this data, right, to drive where the business invests, whether it's development of new features, whether it's the reliability of the service. But how do you go about defining your SLOs? Well, sadly, there's actually no real answer for that. It's hard, it's complex, but what you can do is start with base principles. Keep your SLO definition simple. You'll find that what you do over time is you iterate over this definition until you find something that properly represents your interactions that the users have with your service. Revise, you learn, you improve. That's pretty much the secret to having a good SLO. So none of this can actually happen without having the agreement and support from various different business entities. What we need is a common language. What we need is a way to ensure that each of the teams are all striving for the same goal. This is where SLOs and SRE bridge between the groups in business, the development teams, the operation teams. They provide that common language. SLOs provides it. With having SLOs, your business is able to understand whether 100% reliability is what they really want. You can use tools to, start conversations with these groups if you're having difficulties. I know it's not easy, but emphasize maybe to those in business that as I tend towards 100% reliability, these costs are exponential. The users don't really need 100%. What they need is something lower. Maybe the business is not willing to spend the cost for maintaining their target. With development, they want to release new features, and that's great. We want to encourage new features. That's what potentially brings in new customers. But if it's coming at the cost of the reliability of the service, it doesn't matter. You're not going to have any service to work with. So what do we do on a day-to-day basis to defend these SLOs? What does SRE look like? There are a couple of key areas of expertise that we have. Many of these you've seen in the industry already: metrics and monitoring, capacity planning, change management, emergency response. These are all critical, and I hope everyone has that already. But above all of them is culture. Without culture, we wouldn't be able to do what we do today. We need to have good, healthy discussions across business, across management, across development, across operations. If you're not even seeing eye to eye, you're just going to be stuck and not be able to move forward. Getting into some of the actual attributes of an SRE, monitoring and alerting, this is where sort of the SLO story comes into play. You're monitoring your user interactions, you're alerting when you violate your definition, your agreed upon SLO for the service. When it comes to alerting, we sort of recommend two priorities: paging and ticketing. If you didn't do that, all your tickets are equally important. Or the way I like to see it is each of them are unequally important, right? So equally unimportant. It's a pretty scary story if you have a super noisy but urgent alert or page. You tend to burn out your engineers. The service is losing the attention it needs if everything is same. Obviously, some errors are not page-worthy compared to the whole service being down, right? Measure them correctly and alert on them correctly. To serve traffic, we need capacity, we need machines. What you can do is you can capacity plan, and do forecasting to ensure that you're able to serve the demand that you need. Plan for organic growth, plan for inorganic growth. There are some techniques that you can employ. For new launches, have the capacity, have those machines ready before you actually do the launch, right? Don't expect that only some percentage of users are going to adopt the service. Plan for it ahead. For unexpected events, maybe like the World Cup is having, and you suddenly see a massive spike in your service. Maybe what you need to do is invest in automated solutions that, based on resource utilization, scales your service. It introduces new machines. It launches a new location automatically. Out of all of this, as the service grows, you can't actually scale the capacity with it. It's not easy. So make sure when you do capacity planning, you're looking at the cost per query and scale appropriately. Tying in with this, the other side of capacity planning is efficiency and performance. I mentioned that with the cost per query. Capacity can be expensive. We need to optimize its utilization. We need to understand where our resources are being spent, whether it's due to a new launch or whether you've introduced a memory leak as a part of the newest binary release. The business only has a finite amount of money and a finite amount of resources. We need to make sure that we're investing appropriately. This is where that whole SLO story comes into play as well. Imagine you've got this defined reliability target, but you want to make your service super reliable. You build it 10x. What does that mean? That means you have 90% of your resources being unused. What's the point of that? That's a cost to the business. Scale your services based on the actual requirements of your SLOs and the resource utilization. Don't waste it. Development teams, you can work closely with your development teams, use common infrastructure across theirs, tooling, and yours to make releases faster. And that's good. That's what we want to encourage. But the reality is that most of the outages that we see today are due to changes to the live production environment. You don't want to say no. What you want to do is manage and minimize these risks to production. And there's a couple of things that you can do to achieve this, right? Implement progressive rollouts. Start with a canary location. Once that's good, move forward. Start introducing the changes to new locations and then go out for a global release. I think everyone knows the story of canaries. I think it was something like the miners wanted to test if the mine was poisonous or something. They sent in a canary. If it came back, it was good. If it didn't come back, I think you know what happened there. Have appropriate monitoring. We want to reduce the mean time to detection for these failures as quickly as possible, right? Have the appropriate monitoring for the servers during these rollouts and appropriate alerting to make sure that you're being notified. Build automation. Make sure these rollouts are actually released automatically. Make sure the rollbacks are automatic. If your rollbacks are not automatic, at least document these procedures. I need to emphasize this. I've seen so many cases where the services are so interdependent, that when you do like a data release, a data push to 5 different services, you see some errors in one of them. You do a rollback, not realizing you've actually introduced a major issue, a black hole, because of how the interdependency between the services are. Document these things, at the least. And yeah, automate it, try and remove the humans from the loop. One of the things that I would recommend is, if you do detect an alert, right, maybe ensure that when the alert is fired, stop the rollout automatically. Don't wait for a human to react to that. Just pause it. There's no cost to that. It's only going to make things better, at least, if not automatically roll back. Everyone wants to move faster. We want our developers to be able to release features as quickly as possible. We said that 100% is the wrong reliability target. We have a downtime that we're willing to tolerate. Use that downtime. Use that error budget wisely. Allow your developers to release, to push experiments. You need to do this, otherwise you're going to be wasting your resources. The goal is not 0 outages, but it's to maximize your velocity within that error budget. Within that error budget. One of the things is you need to also have appropriate policies around this. You do have an error budget, but if they exceed it, what are you going to do? Have the policies to say, we've implemented a change freeze. Stop releasing until we recover these rollouts. I know that might be harsh, but the reality is that we need consequences for the actions that we take. The development teams can use these error budgets. What they can do is they can self-manage. This comes back to that benefits of error budget, right? They have that control feedback. They know when they're teetering at the line of error budget, of the error budget violation, and they can say, oh, maybe we'll do the release slower, we'll roll it out to a few cells. They can do this themselves. They can self-manage. Provisioning. When I mean provisioning, it's sort of like a combination of change management, capacity planning. This is where you're increasing the size of your service within a location or introducing new locations. This needs to be done quickly. Capacity is expensive, and we don't want to have unused capacity. But at the same time, it needs to be done safely. Make sure that when you do add a new location, it's tested. I can think of a scenario where you have a service that's having some resource issues, you're serving some errors. What you do is you quickly launch a new location. You have a load balancing solution. It's now shifted the traffic across all cells, including the new one. What if you had some flags that were enabled in production that the new location doesn't, right? And these flags are actually black holing all the traffic that's hitting that new location. You've actually made the situation worse. I'd rather take the hit of a few queries dropped compared to black holing a lot more due to how load balancing has shifted more of the traffic to the new location. So make sure you test it. Emergency response. This is something that SREs are well known for, but what people don't realize is that training and support is largely responsible for our success here. These situations can be stressful. Users are unhappy, the pages are going off. What you can do is have appropriate documentation, ensure that you have processes around this, as well as regular training. Do mock situations. Test out your failure scenario that you had last week during your on-call reviews that you hopefully do weekly. And this actually helps you with the live incident. There's actually a couple of other things that you can do. Don't panic, that doesn't help in any way. Understand that you're not alone. You're working in a team, you're all maintaining that service, and you're sharing the same goals there. Don't be afraid to escalate. Don't be afraid to page someone. If you're waking someone up at 2 a.m., it's fine. They're on call for a service for a reason, so waking them at 2 a.m. is not an issue. Mitigate, troubleshoot, and fix. It's in this order for a reason. Mitigate is what your goal is initially. Get rid of the problems and make sure that your users are happy before you start doing deep dive troubleshooting. What's natural after an outage is the postmortem, so you want to do a write-up of the incident. But what's important to understand is that not all incidents needs a write-up, but you need to express this to the business. You need to have some sort of threshold that defines when you actually raise an incident report. Some of the things that we use is just things like user visible downtime. That's a threshold that we can use. You can often tie this back to your SLOs as well. Postmortems is vital to our culture. This is how we learn about our mistakes. And this is how we ensure we don't make these mistakes again. It's really stressful when you see that outage repeated in production over and over again. I hate it. And there are a couple of things that you can do to ensure you have sort of a good postmortem etiquette. One of the things that I would say is, while you're troubleshooting, right, make sure that all the actions that you're taking is being logged. If you run a command, make sure you have enough space in your machine to log all of these commands that you've executed and timestamped. If you are looking at graphs, time lock your graphs, save those graphs. If you have an IRC chat with 10 engineers, log every single sentence, every single word in that IRC chat. You wouldn't know how useful all of this information is when you're trying to ascertain what the root cause was, especially with the timestamps. Some of the other things that you can do is have effective preventative action items, as well as action items that reduce and mitigate the risk for future or similar types of cases in the future. Have SLOs around these action items. We want to make sure that these are actually completed. It's no good writing a postmortem saying this is what we need to do and not following up. Blamelessness. Postmortems are blameless. People are not the cause of incidents. And you might be laughing or find that hilarious when I say that. But this ties back to what Gaurav said at the beginning. We treat operations as a software engineering problem. We don't look at it as who made this mistake, but rather why did the system allow for this mistake to happen? You want to find out the root cause of the incident. It doesn't help if the people involved are scared and can't, and are not willing to speak up about it. Yeah. So humans are never the cause of the mistakes or the incidents. The mistake is allowing, the service to accept that error, something like that. Toil, it's unavoidable. SREs, we're 50% SWE, 50% SRE, ops. We do the whole lot. What's important here is that you are having the ability to make decisions on when and what to automate, use data to drive these decisions, find out where the most of your toil is, and try and tackle these problems first, if it's feasible. Small wins are good as well. Big wins are great. Make progressive changes. It doesn't help when we throw engineers at the problem of toil. Hire more people, they'll solve it. That doesn't scale. The business has only a certain amount of money, and they can't invest it in engineers to solve the toil problem. You can't just have 20 people working on reducing the workload. What they need to do is focus on building automation, make the problems go away. It's never good if you have someone burnt out, right? If they're burnt out, they're probably going to leave your team. It's undeniable. It's reality. When it comes to team skills, I mentioned it before, we're 50% SWE, 50% systems engineer. We really, really like this sort of mix. We have expertise from both sides. But to ensure that we balance the project work, everyone needs to be able to write code. You need to be able to build those automation tools. And lastly, empower your SREs. They're the ones that manage the service. They're the ones that understand it. They're the ones that operate on it. If they tell you that, we're close to falling over, listen to that decision. Otherwise, you're probably going to have some sort of outage that happens, and you're going to pay a cost for that. Give them the tools for escalation. Give them the ability to make the decisions they need to make. A recap of sort of the SRE best practices. This is how a couple of the topics we talked about fits into the 5 areas that we've mentioned there. Forecasting goes into capacity planning. Our SLOs is in metrics and monitoring. Culture, toil management, engineering alignment. This is all important. And just a bit off the slides, there was a question earlier about what do we do about a disconnect between managers and engineers, right? I think we've solved the problem. Your manager is on call as well. Have them deal with the same problems that you're on call for. Seriously, that's how we do it. It works. I'm just telling you. Only people 5 levels above you, they're the only ones that are not on call. 2 levels above, they're on call. They do it. And this is sort of linking back how SRE implements DevOps. You can see that we've got these 5 areas, and you can tell how the work that SRE does fits into this, but it's a lot more as well than what we've just shown here. Really, at Google, the SREs are able to drive decisions, and management as well as different organizations, we work together and we have healthy discussions around what the user wants. That's really what we're aiming for. And with that, I'll hand it back to Gaurav.
Yeah, thanks, Rahul. So, yeah, I think pretty much of the principles, practices, and expertise around SRE, which Rahul discussed, how can you guys within your organizations get started? So probably these are the 4 things which you can kind of start with. The first and foremost being define SLOs. You can't define your error budgets if you haven't defined your SLOs, and that is a very critical path, and a problem to solve, within the entire SRE practices. Hire people who can write software. So, as Rahul mentioned, have a good mix of people within your team who are actually the SREs, having that SWE and system engineering knowledge. make sure the operations and the development teams are treated equally, and have that feedback loop within your organization. So, for example, if there is a service which an SRE team is responsible of managing, and the product team isn't kind of responding back to them, SREs can choose to drop that service and not kind of manage it and then go ahead with next service. So have that culture within your organization and have them empowered. So pick one of the services and run the SRE model. Make sure you have strong executive sponsorship and support. Culture being one of the most important things at Google, which we have seen across all different teams, and especially the way it works between the SRE, development, and business. And again, SLOs being critical, and measure everything, whatever you define. That's the only way you can define success. So once you have done with one of the models, then probably you can be an advocate within your organization and try to scale that same model across multiple teams within your organization. And it's an iterative process, right? You can kind of get to very good SLOs, not probably in the first instance. That's, again, a repetitive process. So the ways in which Google can help, we do have a team which we call as Customer Reliability Engineering Team. It's a team which is being kind of formed by some of the Google SREs. And this is like for some of our customers who use our cloud platforms. And these are some of the areas in which we kind of help them, kind of conducting reliability reviews. We help them build shared monitoring and alerting. We also kind of make sure that they're ready for some of their critical periods within their businesses. And we also do joint postmortems as well. OK, so lastly, these are some of the books which you can kind of start with, and that pretty much aligns to all the principles and practices which we kind of spoke in today's session. The workbook came in July, August this year, so you can kind of, if you haven't read, we would highly recommend that as a read. And the first one has been there for 2 years now. I think we are just about time, so thank you so much. We are happy to take any questions from you guys because we are here during the day in the conference. So thank you so much.
Yep, thank you. Wait, we have questions now?
Okay.
Okay. I was expecting offline questions, but sure.
Oh, sure.
No, if it's, I can answer one. Maybe.
Okay, we can take one.
The first and last question, guys.
Okay, I'm a lucky guy. Okay, the question I have is like, can you just give an examples of like SLO? Maybe you said like you work with the Google Maps team. Can you give me an how does that look like?
Yeah. So one of the SLOs that you can have is the number of 200s that you've served based on the total number of queries that you've received, right? That's a simple one that's better than uptime of your service. But SLOs go, I think that's the question, right? You were talking about SLOs, right? Yeah. So, but SLOs are far more than just the 200s. It really depends on what the service requires. I'm not sure if many of you actually measure this, but data quality, that's another aspect and dimension that you should have well-defined SLOs for. And it really depends on what the requirement of the customer is. Maybe you are, returning routes and they need at least 5 responses. And if you're not able to serve at least 5 of them, that's maybe a violation of your SLO. This is just a very small example, but, have more than just simple things such as I'm returning a response. Maybe even consider things like the quality of the response as well. We do talk about it a lot in the books, and it's not an easy problem to solve. Cool.
Okay. Thanks.
Hope that helps.
Okay.
Thanks
So much, guys.